But I think the deployment phase is actually quite underestimated. It also brings a lot of its challenges you can have based on your deployment environment and use case. So you have then the requirement that comes about throughput, size, cost, accuracy, of course, response time. There's a lot. Like a trap I've seen several times the customer doing is often that to really go for the state-of-the-art model, the use case is mainly driven by one metric, the accuracy, but not really care about the rest. And so I think it can be the trap here. So really your choice of model architecture should really be you should really have it in mind from the start.
Every use case, of course, during operations, it is still continuous learning process to understand what else needs to be improved and how we can make every use case even more successful.
How are we going to monitor this model or this technology over time? As the data changes, as the scenarios change, how are we going to be able to monitor it in the wild so that it's actually continuing to work as it was intended to? For error prevention and monitoring, there are a lot of different issues that pop up in the wild when you're done testing on your single held out test set, right? Like this data distribution shift, model brittleness and robustness and bias. And in addition to this, there isn't necessarily a standard for how to monitor these models after they're deployed in the wild.